But you guys are passing with a higher percentage rate than I can remember. Well, summer's always super good. You guys are kind of like, you're close to the level of summer students. I think out of 70-80% of you passing right now. That's good. All right. F of x is 9x minus 8. What are we doing in this section? Inverse functions. We want to find inverse functions. We want to find the opposite function. The last one was exponentials. 8.1 was 8.1, graphs of exponentials and stuff. All right, so we're trying to determine the formula for the inverse. Now, what do we mean inverse function? We mean function that'll do the opposite. It'll do the opposite. That seems kind of weird. Like, what this is a function, right? 9x minus 8, that's a function. You plug stuff into it, and it does something to it, right? Like, you could plug a number in. I could plug in 2 or whatever. What if I, don't write this down. You know, this is what we're going to do, but just want to make sure you get an idea of what we're even doing here. That's a function, which means you could plug stuff in. If I put an f of 2, how would I figure out? If you put 2 into the toaster, so to speak, I always call functions toasters, just to get that plug-in idea. You put bread in the toaster, push down the lever, pops up, it's toast, right? It changes it to toast and spits it back out. Well, that's what functions do. You plug stuff in, does something to them, spits out an answer. So if you plug into, remember how the toaster works? Here, let me write it with the x first off. It's 9x minus 8. It's kind of like that x is where it ends up when you plug stuff in. That's what the x is in a function. It's the holes in the toaster. So if you put in a 2, that 2 will slide right there. And it'll be 9 times 2 minus 8, whatever that is, 18 minus 8, 10. Instead of toast coming out, we get a 10 coming out. Does that make sense? That's how functions work. You know that, right? Put in a 2, changes it, spits out a 10. In fact, what does it do to anything you plug in? It multiplies it by 9 and subtracts 8. That's the multiply by 9, subtract 8 function. Right? Anything you plug in, it multiplies it by 9, subtracts 8 from it. Okay, great. So what? Well, what we want is the opposite machine. So what's the opposite of a toaster? That's an inverse toaster. Well, an opposite machine would have to run things backwards, right?
Untoaster?
Yeah, it'd have to be like an untoaster. Meaning, you take toast, you put it in, push down the lever, comes back out bread. Right? Really useful for your kitchen this Christmas. Right? So no, I'm sort of goofing around, but I'm wanting to get the idea in your mind. That's the idea of an inverse function. It does the opposite. It does exactly the opposite. Turns bread back in, or toast back into bread. So with functions, what do you think? If you just had to guess off the top of your head, Ajane.
Isn't fxy?
It is. Yeah, this is y.
So it doesn't matter.
It is y. You're totally right. That is y. So this is, again, this is the, anything I plug, like what if I plugged a 10 in? What if I put a 10 in? What would it do? Well, you put the 10 right there. It'd be 9 times 10, which would be what? 90, subtract 8, whatever that is, 82. So whatever you plug in, this is the multiply by 9, subtract 8 function, isn't it? So if you had to guess, just a raw guess, which you might do on the multiple choice test if you don't study hard after Thanksgiving. Might be a lot of guessing involved. So I'm just joking. Maybe not a funny or friendly joke. Sorry. So if you had to guess at this point, what would be the opposite of the multiply by 9, subtract 8? What's the opposite of multiplying by 9? Dividing by 9.
And adding.
What's the opposite of subtracting 8? Adding 8. So we're thinking opposite? Opposite probably involves like adding 8 and dividing by 9. That's the opposite of multiplying by 9 and subtracting 8, right? And pretty much that's right. Yeah. So anyway, that's the general idea. Let's get specific now about how you do it. So I want to get the idea in your mind. All right, so what is it you do? It's actually pretty easy. So the inverse, to find the inverse, here's the steps you take. Number 1, you invert. What a surprise. Meaning switch x and y. You just trade, because that's what an inverse function does, right? Like the bread and the toast switched. Instead of put in bread, get out toast, like for a toaster, a detoaster, an untoaster, you put in toast, get out bread, right? So you switch x and y. That's what it means to be an inverse function. X and y trade roles. Step 2, solve for y. So that's really just it. There you go. 2 steps. Switch x and y, invert them, solve for y. So here we go. So we have the function f of x is 9x minus 8. Where's y? I'm saying switch x and y. Where is y? Washington just pointed it out for us. The f of x is the y, huh? Remember that? All function letters, g of x, whatever they give you, that's your y, isn't it? So what am I supposed to do, step 1? Switch them. So everything else stays put. I'm not moving the 9, not moving the 8, not moving anything, but x becomes y magically, y becomes x magically. So this is x here, y there. So that's step 1. I just switched inputs with outputs. X with y. Step 2, solve for y. How do I solve that equation for y?
Yeah, y alone.
Add 8 to both sides, yeah. So we get 9, get y alone, right? X plus 8, everybody good so far? 9y is x plus 8. Last step to get y alone?
Divide by 9.
Divide by 9. And there we go. And it's pretty much like we expected, huh? See how it's adding 8 and dividing by 9, the opposite of subtracting 8 and times it by 9? You could have maybe guessed it on the multiple choice test. Good?
So this is kind of like the formulas that we did. The formulas, like, how do we isolate, solve?
Yeah, in the end, it's solving for a formula. But first, you invert them. Yeah, you just invert them and then solve. All right, okay, so try that one. So here's our function. So that's y, isn't it? Y equals negative 4 over x. You know the two steps. Find the inverse. So the inverse. Step 1, switch or invert x and y. So y becomes x, x becomes y. Switch x and y. We good there? That's step 1. Switch to x and y. That's what it means to invert. Yeah,
So the size never change when you switch it?
right. Yeah, we're not moving. The 4 doesn't move. The negative doesn't change. Nothing. Yeah, it's like a magical change. Like x just poof, y, your y now. At y poof, your x now. Yeah, it literally is just like bread and toast have reversed roles. It's an inverse machine. Now solve that thing. Step 2. Step 2 is solve for y. So how do we solve that equation for y?
Oh, do you do the cross?
Yeah. Whenever we have fraction, put it over 1, diagonal, right? We've done that before, right? Cross multiply when you got a fraction. Just normal steps for solving. Nothing fancy or surprising here. X times y is 1 times negative 4. Good so far. So x times y is negative 4. Good.
Divide by x.
Last step to get y. Yeah, we're trying to solve for y. Get y alone. What do? Divide by the x, huh? There we go. There's the inverse function. Which, by the way, is the same as the original function.
Yeah.
That's a weird one. That hardly ever happens. The function is his own inverse.
Well, it's basically saying it's already solved for y, because y equals negative 4 over x.
Yeah, but that was before they traded roles. This is the original y, but then they traded roles right here.
Okay.
Remember, they trade roles. Inputs become outputs. All right. Okay, so what is f of x again? What's the function letter always? That's y, isn't it?
1.
So it's y equals 2/5 x plus 4. All right, go through the two steps. You know them. Switch x and y. Don't move anything else. Just switch x and y. Then solve for y. Switch x and y. So y becomes x becomes y. Good to there. X and Y have traded roles. Nothing else has moved, right? Just X and Y. Switch. Nothing else moves on the first step. And then we've got to solve that equation for Y. How do we solve that equation for y? Yeah, I would do the denominator first. Yeah, multiply by 5. Remember, whenever we have fractions, we don't like those. I need to remind you, you don't like fractions, remember? And so the way we get rid of those is multiply through by the denominator, which is the 5, exactly. Abraham knows it. So multiply through by 5, and it cancels in the middle, huh? So we get 5x, 2y plus 20. That good? No more fractions now, a little easier to deal with. Keep going. Get y alone. Solve for y. So I'm just going to jump this 20. What happens when something jumps to the other side of an equal sign? The sign changes, huh? So it'll be 5x minus 20 is 2y. What do we do now to finish getting y alone? Divide by the 2. Let's go divide by 2, divide by 2. So what do we got? We've got 5x minus 20 over 2. Can I cancel the 2 into the 20?
No.
No, because of the glue. If it went into the 5 also, then I would do both because they're glued, but it doesn't go into the 5, so I just stop right there.
Do you? Oh, okay. I was going to say, do you have to factor the 5 out?
You don't. That good? That's the inverse function? Are we happy about that?
Yes, because this is easy.
I think it is a little easier, yeah. No questions? Good? All right. Okay.
Determine if it's 1 to 1.
Yeah, I'm skipping all that. Don't pay any attention to all that. Term whether it's 1 to 1. That's a pre-calculus concept. You want to learn about that? Take pre-calculus. So the next course, if you're moving up the line in math science, next course would be trigonometry, math 4A, and then pre-calculus. I talk all about that in pre-calculus. So ignore it. You won't ever have to do anything with that.
Until pre-calculus.
Right. All right, so try that one. Just find its inverse. Switch x and y, solve for y. So y equals 5 over x plus 6. Switch x and y, solve for y. Good. So step 1. Switch x and y. Good to there. So I switched x and y. And then step 2, solve for y. Yeah, cross multiply for sure. Yeah, when you just have one fraction on each side, you'll make x over 1. Always cross multiply, huh? Everybody with me on that? Whenever you just have one fraction on each side, you cross multiply, don't you? Back here, I had more stuff going. I had 3 things, didn't I? So I couldn't just cross multiply. So cross multiply is when you just have one fraction each side. That's what I have here. Just x over 1 and 5 over y plus 6. Just one fraction on each side. Cross multiply. Distribute. xy plus 6x equals 1 times 5 is 5. Everybody good to there so far? How do you solve for y? Y is saying, here I am, and I want to be alone on my side of the wall.
Subtract 6x.
So jump this 6x or subtract it to the other side. divide by x. Hey, can I cancel those x's?
No.
Why not?
Plus and minus.
Costco says no. Huh. Things that are plus and minus are glued together. You buy the whole package, you go like this and buy the whole package, or you buy none of it. Right? So we can't do it. So it stays just like that. Real important in this section, because otherwise you get the wrong answers on the multiple choice test on this section. Because they'll give you those options. Is that good? We good with that? Making sense how to find the inverse? You just switch x and y, solve for y. Switch x and y, get y alone. Right? 7x plus 1 over 4x. Was that number 5?
Yeah.
Okay.
4x plus 2?
Over 4x plus 2. They want me to find the inverse of that one. Let me do this one with you. Oh, that was f of x equals, wasn't it?
Yeah.
Number 5 here, getting a little scribbly. Okay, so what do? Well, f of x, you know that's y. And step 1, switch x and y. Now, what about, we have 2 x's, right? It could be 1,000 x's. Every x will become a y instantaneously. Nothing else moves. Nothing else at all moves. The y will become an x, and the x's will become y's.
Well, this is just another proportion, right? And just cross multiply.
Right, there'll be more to it, though. Everybody good so far to there? Step 1, switch x and y. X's become y's, y's become x's. Now, cross multiply is correct, because we do just have one fraction on each side, so it's true, we can just cross multiply. X times 4y plus 2 is 1 times 7y plus 1. Good to there. Distribute. Boom, boom. 4xy plus 2x. Boom, boom. Some y plus 1. We're supposed to solve for y now. We good to there? Okay. Everybody good to there? Caught up? Because there's something new here. Now, notice there's something difficult about y right now. What's difficult about y?
It's on both sides.
Yeah, it's in 2 places on both sides. It's there and there. So that's not so easy. We can't just subtract and divide or something more fancy. Abraham, these are your favorite, I remember. That one exam, right? You're like, I can't believe. So we did have this. I remember talking with Abraham after exam 2 or 3 or whatever it was. We've done this before, and you guys never forget anything we do in here, right? Remember it all perfectly?
This was big on this one formula.
This was big. When y is in 2 locations to serve you better. When y is in 2 locations, what do? You, step 1, get them on the same side. You get those 2 y's on the same side, and then you factor out y and divide. Yeah, so this is a whole rigmarole here. When you got y in 2 locations, you've got to say, okay, I'm going to get the 2 y terms on the same side. Which one? The 4xy and the 7y. So I'm going to grab this guy, I'm going to jump him this way. So that'll put both the y terms on the left. I'm going to grab the 2x and say, you go on to the other side. So what do we have now? 4xy minus 7y is minus 2x plus 1.
I did the exact opposite way.
That's okay, yeah, you can go either way.
Okay.
You can move the y's to the right or the left. Good so far? See how I got both the y terms? They're on the same side now. So get the y's, get them on the same side. That's a G there. Get them on the same side. And then, remember, trying to get alone. How do you get that y alone? Factor it out. See what I mean? See how we factored it out?
Mine's like the reverse mirror image view, so I'm like trying to see if it's still right.
And last step to get y alone, factor out and divide. Divide by 4x minus 7. Boom. There it is. We did it. So what did I get? Bring it up here and write the answer. I got minus 2x plus 1 over 4x minus 7. Did you track with all those steps? Ashne?
Is there going to be any time where you have to reduce the answer?
Sometimes. It's not usually.
Because it's, oh no.
Yeah, this one can't be. Because you can't go like 2 into 4, because again, they're glued. It's all or nothing. So, is everybody good with that? Is that making sense? What y'all think? That okay? Everybody see what I did there? So, I just switched x and y. Then I cross-multiplied. And I noticed I had y in 2 places. What do you do when you have y in 2 places? Get them on the same side, factor the y out, and divide. Now, let me ask you this, guys. You guys are going to take a multiple choice test on this thing. What if they had the following answer? 2x minus 1 over minus 4x plus 7.
Yes, that's right. Because that's my answer.
What if they had that answer? Is that the same?
No.
Because the x is negative.
It is the same. And the reason you can tell is because every sign has been switched, which means they multiplied top and bottom by minus. They didn't really. They just happened to put the y's on the other side. It just naturally came out that way. Meaning, but you'll need to know that on a multiple choice test. If you get this answer and they have that or vice versa, you'll need to know, well, how do you know? You just check by multiplying top and bottom by minus 1. So if I took minus 1 on the top, see how I'd make that plus 2x and negative 1, and then on the bottom, minus 4x and plus 7? See how it would become the same thing? And if you're multiplying top and bottom by minus 1, top and bottom, you're not changing anything. So that means this answer is really the same as the other answer. So if every sign has been changed, top and bottom, that's the same thing. You haven't changed anything. Right? It'd be like if I took 2/3 and I went, well, I'm going to make a minus 2 over minus 3. That's the same thing. Isn't it? 2 negatives is positive. That's another way to say positive 2/3, isn't it? You see the deal? If you multiply top and bottom of a fraction by negative 1, you're getting the same answer. So if they have it that way, that's all they did. They naturally got that answer because they put the y's on the right side. That's all that happened, as Renee was saying. Car, do you have a question on that?
No, I was going to say, even if you put the x just in front of the fraction part of it,
What's that?
still mean the same thing.
What are you talking about?
So instead of putting it either above or below, if you put it right there.
Oh, a negative sign?
Yeah. Wouldn't it mean the same thing?
Right, but when there's plus or minus, it has to distribute. You got to be a little careful. Yeah, I know what you're saying. You're remembering correctly that a negative in the middle is the same as a negative on the top or a negative on the bottom. Correct. Well said, well remembered. But you've got to watch out for this trick. What if you had like x plus 3 over x plus 7? Okay, so negative in the front, yeah, is the same as negative on the top, right? But when it goes to the top, and now there's 2 things in the top, it won't just hit the front guy. It'll hit the whole top. So it'll become minus x minus 3.
Okay.
So that's the only thing to watch out for. Yes, front, top, bottom, all the same. But when you go to the top, if there's more than one thing, it's all the top. The common mistake is everybody thinks they can just hit the front of the top. To go to the top means to go to the whole top.
Okay.
Changing every sign on the top. Or the bottom. Same thing. Right. We good with all that? That making sense? So make sure you're aware of that on the multiple choice test. That becomes 6 x to the 3 minus 2. Try that one. Find the inverse. Find the inverse function for that one.
Oh.
Could we?
So this is y, switch x and y. Switch x and y. Solve for y. Right? Get y alone. So add 2. So x plus 2 is y cubed. Good so far? Okay, so how do I finish getting y alone there?
Cube rooted?
Cube rooted, huh? Yeah. Cube root, good job. Cube root's the opposite of third power, huh?
You can just leave it like that, right?
Yep.
Okay.
Yeah, that's it. You're right. You don't need to write anything else. That's it. Cube root of x plus 2. Everybody good with that? That's how you get rid of a third power. You do a third root. Powers and roots are opposites. Questions I can answer? We all good? Is that number 8? I'm losing track over here. Yeah, cube root of 3. So I'm just going to rewrite it here. Number 8 is number 7. Cube root of 3x. So this is number 7. F of x equals cube root of 3x. All right, so find the inverse function for that one. So what do we do with the cube root? We third power, right? Well, actually, I should switch x and y first, huh? I forgot. So this is y right here. Switch. So step 1, switch. This should be 1. So step 1, switch them. Step 2, y is saying I want to be alone, so we gotta get y alone, which means we gotta get that third root off of it and stuff. So how do you get y alone now? Third power it, huh? So we got cube root of 3y, we got x, and then we just say, okay, third power. Because again, roots and powers are opposites. Are you getting that theme? That's a big theme we've seen recently in the algebra we've been doing. Roots and powers are opposites of each other, aren't they? So just like the last problem, number 6 here, we had a third power. How did we get rid of it? Third root. This one, we got a third root. How are we going to get rid of it? Third power. They're opposites. They're antidotes, right? They get rid of each other. Powers and roots. So this is what? X cubed is 3y. Got rid of the root and the power. They canceled over here, right? They both cancel each other out. Last step, solve for y. Divide by 3. Here it is. X to the third over 3. The inverse function. We happy? Okay, so there we go, number 8. And it says y equals 5/2 x minus 1. So first off, find the inverse function. First, find the inverse. I'll let you do that. So switch x and y, get y alone. Switch x and y, get y alone. So these guys switch. So step 1, switch them. Step 2, get y alone. So how do we get y alone? We multiply through by the denominator, right? We all good with that? Whenever you have a fraction, this is not just one fraction each side, is it? So we can't cross multiply. Does everybody see that difference? It's not just one fraction each side. So we got to multiply through. What do we got? 2x is 5y minus 2.
Add 2 to both sides.
Good? Everybody good to there? So now, yeah, add 2 to both sides. Last step to get y alone is divide by 5. Boom, there it is. There's the inverse function. Good? That okay? Now, what they want me to do is graph them both. They want me to graph them both. How am I going to do that?
First one's easy.
Yeah, I agree. The first one's easy because here's the original function. They want me to graph the original and the inverse.
That's mx plus b.
They want the original red and the inverse blue. Okay, so I shouldn't have done a blue circle there. It's not a blue. Never mind. The original they want red, and the inverse they want blue. Okay, so the original here I'll do with red. How am I going to graph that thing? Remember how to graph? Those are both straight lines. You start at this point, right? So you would start at down 1, -1. Start at -1. Remember that? And then you rise over run. Go up 5 over 2. Right? So let me do that. So up 5 over 2. Up 2, 3, 4, 5. So go up 1, 2, 3, 4, 5 over 1, 2. 1, 2. Like that. That good? So you go up 5 over 2. So you start at -1, go up 5 over 2. There's your other dot. Remember graphing lines from way back when? You start at whatever number's off to the right. And that's right on the center line. Start it down 1, then go up 5 over 2. So I went up 5 over 2, put a dot, connect those two dots. So there's the red one. How do we graph the blue one, though? It's a little more tricky. Well, you're going to need to divide both those. So in other words, you're going to need to put the 2x over 5 and the 2 over 5 separately.
That's what I was thinking.
Like that. And then you start at this point. How do you start at 2/5? Well, it's just multiple choice. Just guess the best you can. It's like a half. 2/5 is about a half, right? So it's about right here. A little less than a half. This is 1, 2, 3, 4. So 2/5 is about right there. A little less than a half, isn't it? Start a little less than a half. Rise 2 and run. Go up 2. 1, 2. Go over 5. 1, 2, 3, 4, 5. Way over here. Connect the dots. Dotted blue line. Whoops. Like that. There it is. Which one of those looks like that?
C.
Yeah, C looks like that, doesn't it? Good enough to tell. Everybody good there? See those two? That looks like C, doesn't it? Abraham.
Can you leave like 2 over 5, 2/5, and then just put the x on the side, or you have to leave the 2x above?
Yeah, you can always put the, because to be in the top is to be in the front. It's the same thing.
Oh.
Yep, right, because x is over 1, so it's always the same. All right. Okay, so number 9, they're saying y equals x plus 1 to the third power. So first off, can we find the inverse? Let's find the inverse function. So do that first off. So switch x and y, solve for y.
Is this going to be like those ones where it's opposite? No?
No, we're not factoring it. Just Just switch x and y, solve for y.
No, like where we find the vertex.
Nope, that's squared.
Okay.
So switch x and y. Switch x and y. So x goes out here, y over there. And then solve for y. So how do I take that equation right there and solve it for y? Yeah. How do you get rid of a third power? Third root. You guys getting the hang of this? Powers and roots are always the opposites. So I take that third power and exactly I third root, and the root cancels the power, doesn't it? Everybody good to there? See how this works? Powers and roots are always opposites of each other. So it cancels out. Last step to get y alone, subtract 1. Third root of x minus 1. Third root of x minus 1. There it is. We got the inverse function. And then we're supposed to graph them both. Well, I would just make a table. It's not simple to graph those. I would just make a table. So let me do that real quick. So coming up here, so for the red one, so I would literally just make an XY table, and I would just say, look, I'm put in 0, put in 1, maybe put in 2. You go higher in math, you learn formally how to graph third power things and stuff like that. So we'll just plug in some points. So plug in, y is x plus 1 to the third power. So that'd be 0 plus 1 to the third, which is 1 to the third, which is 1, right? 1 times 1 times 1. It's just 1. The next one. Plug in 1 plus 1 to the third power, which is 2 to the third power. So 2 times 2 times 2 is 8. So that's good enough. Just do that. So over 0 up 1, over 1, all the way up to 8. See how the thing's rocketing up to the right? If you, yeah, I don't have time. But the other side goes like that. You could plug in -1, you'd find out. That's what x cubed graphs, I call them the big snake when I teach pre-calculus. They make a big kind of snaky thing. That's what x cubed does. All right, now what about the other one? What about the second graph? This one, again, you would plug in xy, which is going to be a little, no, it won't be too bad. Plug in xy, put in 0, put in 1. Put in 0, what is the, y is the cube root of x minus 1. What is the cube root of 0 minus 1? Cube root of 0 is just 0. Minus 1 is minus 1. Over 0 down 1, so it's right here. Put in 1. Cube root of 1 minus 1. Cube root of 1 is 1. 1 minus 1 is 0. Over 1 up 0. See, it's hitting those 2 points. Basically, it's going to go like that. It's going to do a sideways snake. So it looks like it's answer C again, isn't it? Or no, B?
Yeah.
Looks B. B and C are close.
Well, blue does the same.
No, blue go, yeah, it's B. It's B. It's B because blue goes sideways like that, yeah. All right, so there we go. I know that's kind of a little bit of a messy deal. Questions I can answer on that? We okay? So just find the inverse, make an XY table for both. All I plugged in was 0 and 1, 0 and 1 for X. Found Y, put a couple of dots. Yeah, but I knew what the functions looked like. Yeah. You'd have to put in more dots. If you put in more dots, you'd find the way I found the functions. All right, come. That's right. All right. Here is composition of functions. So we have f of x. Let me bring it over here. So f of x is 7x minus 5. And the other function, g of x, is 5 minus 5x. And what they're asking me for is f o g of x, fog. Fog of x. What is that? That's plugging one function into the other. So what they want me to do is plug one function into another here. And the order is important. It's right to left, because they're going to also ask me to go the other way, and that'll change things up. So now think about functions for a minute. Let's make sure I'm making sense of this. If I write f parentheses 2, you guys with me? Am I losing you here? If I write f parentheses 2, what does that mean? Doesn't that mean I put 2 into f? Right? So notice, function notation always takes the thing on the right and plugs it into the thing on the left. That's what function notation always does. So it's no different here. I'm going to take the g on the right and put it into the f on the left. Function notation is always right into left. So if 2 goes into f, then g goes into f. So I'm going to put g into f. It always means right into left. That's what it always means. So I'm going to put all of g into f. What do I mean? Put all of g. I mean all of g goes right in the x slot of f. So it becomes 7. Yeah, I'll change the color to make it more obvious what I'm doing. 5 minus 5x. Everybody see what happened there? Right here where I had the x, 7x minus 5, I stuck in 5 minus 5x. Everybody see that? I stuck in the whole 5 minus 5x there. Everybody good to there? And then you just work it out. So distribute. 35 minus 35x minus 5. 35 minus 5 is 30. There we go. 30 minus 35x. We good with that? Everybody see what happened there? I just put G into F. That's like putting your toaster into your refrigerator. That's putting one function inside the other. What would that do for you?
A microwave, microwaving, a microwave, microwaving, toaster.
What good would it be to have a toaster in your refrigerator? You could have, you take bread, you put it in your toaster, which is in your refrigerator, push down the lever, close the refrigerator door, right? You listen, a couple minutes later the toast pops up inside your refrigerator. You wait a couple more minutes, you open the door, you've got chilled toast, right? Sounds better that way, huh?
Yeah, but it doesn't melt butter.
No. So you get the idea, though. That's what we're doing. We're putting one function inside the other. We're making what's called a composition, right? What's a musical composition? Bunch of instruments all together, one song, right? That's what we're composing two functions, putting one function inside the other. So we're putting G into F. Now, they want us to go vice versa. So over here, they're going to now say, give me golf. Which means, remember, functions are always right into left. So that means F plugs into G this time. So F plugs into G. So go the other way now. Now we take all of F and put it in the X slot. Because remember, the X is the input slot. It's the holes in the toaster. Right? It's where you plug stuff in. So now we're putting G into F. I'm sorry, F into G. Putting F into G. So take all of F, put it into G. Everybody see that? Like they're working? 5 minus 5 times, and then here comes all of F. Everybody see that? See how I put all of F into G's X slot? Make Make that a little more clear.
It's the same thing.
Is that good? And so then we distribute. You can't go 5 minus 5 is 0 out there. Remember, the multiplication has to happen first. Minus 35x plus 25. My 5s look funny.
Plus 5 is 30.
Yeah. So 25 and 5 is 30. There we go. So we're plugging functions into each other. F into G, G into F. So that little circle that's in the middle, it stands for the word of, but anyway, it doesn't matter. Just it's a special symbol, that little circle kind of floating up in the middle of the letters. That's the composition symbol. It means putting one function into the other. And it's always right into left.
So it's the same answer, but not always?
Did it come out the same answer?
Yeah.
Oh. Wow, I didn't even notice that. Not unless they're both linear. Do you understand that sentence? These are both linear functions, meaning he's first power and he's first power. They're both first power functions. Yeah, so if you put one linear function into another, the order does not matter. If one of them is second power or fractions or something like that, it will matter. The order, they'll come out different because one of them has second power. All right, so there we go. So we've got the f of x function equals 4x squared plus 2. And we get the g of x function, which is 3x minus 4. Okay, so what are we going to do now? They're asking me for f of g. So that means, let's do this first one here. So they want f of g. So yeah, remember how it works? It's always the one on the right plugs into the one on the left. So that means put g into f first off. So take all of g and stuff it into f's input slot, his x. And then work it all out. You're going to have to FOIL on this one. All right, how we doing? It's working out. So take all of G and put it into F. Good to there? Let's put all of G into F. Yes.
You put a 2 power on that, is that because the x is 2 powered?
Right. Right, so I put it right there. So the x itself is replaced by all of G.
Okay.
And the x had a 2 power on him, right? And he had a 4 in front of him. He had a 4 in front of him and a 2 power on him. So everything that was on the x is now on the whole G.
Okay.
Because G was stuffed into that slot. Is that good? Everybody see that? Then the square, you know when there's a 2 power in parentheses, you got to write 2 of them. You got to FOIL. So just leave that 4 sitting in the front, and then FOIL. So we get 9x squared minus 12x minus 12x plus 16. The plus 2 still at the back. It's going to be a long one. And then gather like terms minus 24x. We get to there. Distribute that 9 through. Get, what's that? 36x squared. It's getting big here. What is that? 96x plus 64 plus 2. And then combine these two. 36x squared minus 96x plus 66. Tedious. And we're only halfway done.
So
Are we good with that part?
now you have x squared. So What are you supposed to do with that?
We're not doing anything. We're not graphing. We're not solving. We're just plugging in and saying, what do you got? So that's it. We're done. See, there's not an equation. It's not equal to anything.
Yeah.
Right? So that's it.
You take that and you shove it into G.
So this is the answer when you put G
Oh.
into F.
Okay.
That's fog. That's F of G. Right? Remember, we're composing. We're putting our toaster in our, what did I say, refrigerator. Right? We're making a new function out of the two. One function is now in the other. It's now a chilled toaster. Right? It's a new machine. Here it is. The result of composing those two functions together, putting G into F. Now, vice versa, second question, they want us to put the refrigerator in the toaster. That's a little harder to do. All right, we're going the other way now, right? So now we go the other way. We're going to take all of F and stuff it into G. Everybody see that? All of F into G now. So I'll come back over here. I'm going to go the other way now. All of F into G. So all of F into G. So all of F into G. Okay, so if all of F is going into G, what do we got? 3 times F. What is F? 4x squared plus 2. Minus 4. That good?
That's not
So all of F stuffed into G. Boom, boom. 12x squared plus 6 minus 4. 12x squared plus 2. Done. So put all of G into F, then all of F into G. We did it both ways. Any questions I can answer on that? Is that good? Okay. Okay. So here we go. So they're saying f of x is, what is it? F of x equals 5x squared minus 5. And g of x is 2 over x. Okay, so this first one, they want me to find f of g. All right, can you find f of g on that one? Which way do we plug functions? Right to left or left to right? How does it always go?
right to left.
Right goes in the left. Put the G into the F. So all of G plugs in right there to F, right? Put it in the X slot. That's the input slot. That's the holes in the toaster. Is that good there? Now work that out a little bit. Do you know what I mean by work that out a little bit? Just so you got the 2 power on the whole fraction, so that means square the 2, square the x. So what's 2 squared?
4.
4, and then the bottom is just x squared. Good so far? Just square this. So the square, the 2 power on the parentheses came in and did his thing. He 2 powered the top, 2 powered the bottom. Good so far? Yeah.
So why don't you have to do 2x, 2x, instead of squaring it?
Oh, yeah, you totally could.
Oh.
Yeah, you're saying why don't we have to write 2x, 2x?
You didn't have to do it, but
And, right, what if we did that? What would we get? 2 times 2? X times x? Yeah. The reason you don't have to is there's no plus or minus. It's the same reason that makes everything else hard in algebra. If there was a plus or minus in there, then you must write the 2 parentheses, or it actually won't work out correctly. If you don't see how the 2 and the x here are just divided, they're not added or subtracted, no glue, no Costco problems, then you can just square the 2, square the 4. Yeah, good question. That's the answer to all the hard things in algebra. Pluses and minuses, got to do it the hard way. That's basically it. If there's not, you can just do the shortcut. Yeah, but it's always okay to do the long way. Like it was okay to write 2 of them. It just isn't required. I could just square it, done. So we good to there? What do you do now with a whole, we don't leave it like this, right? What do you do in a whole number? It's multiplying a fraction. Over 1. And he goes to the top. Right? You guys with me? 5 is over 1. So he's going to really multiply the top, isn't he? 5 times 4 is 20. There we go. There's our answer.
So that was fog.
That was the fog. Let's go the other way. Now for the golf. G, so let me get this out of the way. G of F. So now F is going to be plugged into G, huh? It's always right to left. F into G now.
You have to factor
So all of F into G. So we get 2 over 5x squared minus 5. Done. There's nothing more to do.
Thank God. See
what I did there? I just plugged all of F into the X slot, which is the denominator, for G. You guys getting the hang of this? It's okay. I can't read you today. You guys give me the poker face again. I don't know if it's making sense or it's not making sense. Is that okay?
How is it we're not doing anything else to it?
What's up?
How is it we're not doing anything else to it? Or is that the answer?
Yeah, that's it. We're not doing anything else. That's it right there.
Even if you factor,
No.
you can't
How
cancel
is
anything.
it that we're not doing anything else to it?
We just plug it in, and any simplification we can do, we do. But there's nothing more to simplify. Whereas the last one, we had to actually square because there was a 2 power on something, so we always have to work that out. And then a 5 times it, we had to put it over 1, But there's nothing like that here. There's nothing more to do. All right.